Okay, so this is your video for 9.3 over composite figures. If you're good at area of regular figures, this should be no problem. A composite figure is a figure made up of simple shapes such as rectangles, trapezoids, triangles, and circles. To find the area of a composite figure, find the area of the simple shapes and then use the area addition postulate. So basically, we're going to have a rectangle stuck on top of a trapezoid, find the area of each one, add them together. No big deal. All right, here we go. Find the area of the shaded figure. So here we have a trapezoid and we have a semicircle. I like to write my plan because this one's pretty easy, but the other ones might get more complicated, and you have to kind of remember, if I'm grading this, the more you write, the more partial credit you're going to get. So trapezoid formula, 1/2 base 1 plus base 2 times the height, plus the semicircle, 1/2 pi r squared, 1/2 32 plus 20 times 14, plus 1/2 pi times 10 squared. Make sure you're using 10 for the radius, not 20 for the diameter. Don't fall into that trap. Okay, so for the trapezoid, 1/2 times 52, times 14. 364 plus 100 plus 50 pi millimeters squared. Okay, so these are going to have two separate ones because this one's in terms of pi and this one's not. If they were a trapezoid and a rectangle, you could add them both together, but these aren't like terms because of the pi, so we're just going to leave them separate. Okay, pause and try B and see if you get it right. This one can be divided up in several ways. The easiest way is in two shapes, a big parallelogram and then a triangle right here. You could have done a trapezoid, a triangle, a triangle, a triangle, but then you're just making more work for yourself. So parallelogram, base times height, 8 times 5. Triangle, 1/2, base is 10, height is 5, 40 and 25. So together that is 65 feet squared. Okay. Find the area of the shaded region. Now I hope yours you can see that the shaded region is basically what is in the circle but is not in the trapezoid. So same kind of thing, except for this time we're going to do circle minus trapezoid. So pi r squared minus 1/2 b1 plus b2 times the height. So again, the radius is 10. Make sure you use 10, not 20. 12 plus 20 times 8. And then this would be 100 pi minus 32 times 8. 128 centimeters squared. So the only difference here is this one is subtraction instead of addition. Okay, word problem. A company receives an order for 65 pieces of the fabric in the given shape. Each piece is to be dyed red, and to dye 6 square inches of fabric, 2 ounces of dye is needed. So how much dye is needed for the entire order? So the first thing we're going to do is find the area, and this is a composite figure. This is a square plus 2 semicircles, so it's just a square plus a circle. So base times height plus pi r squared. 3 times 3 plus pi. Now if this is 3, then the radius is just going to be 1.5. So make sure you're using radius, not diameter. Now this is a word problem, and so we are going to use pi, and I suggest you use the pi button. So we're going to use pi. So 9 plus pi times 1.5 squared. So this is, the area is 16.0685 blah, 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 blah. So I'm going to hold on to that number in my calculator just like we did with law of sines and stuff, just for accuracy. So this is just the area of one circle, or one heart. Remember, they're ordering 65 of these. So the next step, and I'm just going to keep this in my calculator, and I'm going to do times 65. So the area for the entire order is 1,044.5, or rather 0.45, blah, 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 blah. Okay, so that's the area for all of it. So now it says to dye 6 square inches of fabric, 2 ounces of dye is needed. So let's divide this by 6 so we can figure out how many batches I'm going to be dyeing in. Because basically this is saying I'm dyeing in 6 square inch batches and it takes 2 ounces per batch. So I'm going to divide this by 6. And that means I'm going to need 174 blah, 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 blah batches. And then it takes 2 ounces per batch. So now I'm going to multiply by 2. 348.15 blah, blah, blah. So then it says how much dye is needed for the entire order. So let's just call that 349 ounces of dye. Okay, so not a very difficult word problem there, but many steps nonetheless. So we had to find the area of the composite figure, multiply it by 65 because I have 65 of those, divide it by 6 to get it into 6-inch batches, multiply by 2 because 2 ounces per batch, and then there is my final answer, 349. Okay. To estimate the area of an irregular shape, so an irregular shape is just going to be kind of like a blob. You can sometimes use a composite figure. First you draw a composite figure that resembles the original shape, then you divide the composite figure into simple shapes. So there are many methods of how to do this, and one person's might not be exactly the same as the next person's, but you could both be okay. Also, this is going to be an estimation of the area. We can't find the exact area of irregular figures, but we can get close. So one of the methods for breaking this into shapes is to use each row. So I already accidentally started this one, so I call this right here a triangle. This next row right here would be a parallelogram. Here, this would be a trapezoid. And then this bottom would be a triangle. Now, this is definitely not the only way to break this up. You could do triangles around the edges and a big square in the middle. It just is up to you how you want to do that. You might want to stop and think about it up front, because the better you break it up front, the easier your work's going to be at the end. But there's no exact right way to do this. Okay, so now that we broke ours up, we're just going to find the area of each one. So A is a triangle, 1/2 base times height. 1/2, 1, 2, 3 for the base, 1 for the height. So this is going to be 1.5. B is a parallelogram, so base times height. Base is going to be 1, 2, 3. Height is going to be 1. So that will be 3. C is a trapezoid. 1/2 B1 plus B2 times the height. 1, 2, 3 for base 1. 2 for base 2. The height would also be 1. That's one of the other benefits of using each row, is because you're always going to know how much your height is. So 5/2. And D is another triangle. And it's another 1.5. Oh, I'm silly. I was doing the trapezoid formula because that was right above me. How about it's 1, because it's 1/2 base times height. So 2 times 1 is 2. My bad. Sorry. So then once you get the area of all 4 of your simple shapes, then you can just add them together. So this is going to be 3, 4, 5, 6, 7, 8. 8 square units. Now this one worked out nice because all of the sides, the bases, and well, all the heights were 1, and then all the bases appeared to be pretty exact. This one was exactly 3 and 3. And this one was 2 and 1. So this one worked out pretty well. Now on the next example that you're going to do by yourself, it's not perfect going through each of the intersections, so you may have to estimate. The base is 1.2 or the height is 1.5. So pause here and try the last one. Okay, so for this one, again, there are many ways to break this up, but I chose to do here a trapezoid, a triangle, a trapezoid, and a little triangle on the edge here. So for the first, I'm going to zoom in a little. So for the first trapezoid, I said it was base was 1 and 2, and I said the height was 1.25 because it was just a little bit higher than 1. So an area of 1.875. The triangle over there next to it, 1/2 base, I said the base was 1.5. The height was 1, so that is 0.75. The trapezoid, I said the base was, one of the bases was 2.5, the other base was 3, so that makes it an area of 2 3/4. And lastly, the triangle, I said it was 0.8. You could have just as easily said 0.75. So that gave me an area of 0.4. And then I just added those 4 together to get an area of 5.78. Now again, this is just going to be an estimate. How you want to break it down might be different, and how you estimate might be different. You know, you could have said this was 2.7 or something. But we should be in the same ballpark. If I'm in 5.78, you shouldn't be at 12. Okay? All right, see you tomorrow.